All right, so I believe this is recording. Let's take a look at the solutions of, let's try and solve these two quadratic inequalities. Here in number 7, let's jump in and instead of having it greater than or equal to 0, let's just set it equal to 0 and solve this equation. But when we look at this, I don't believe this is going to factor for us because x times x will get us the x squared, and 2 is a prime number, and the middle term is positive. So if we have plus 2 and plus 1 here, that would have a middle term of 3x. So this x squared plus 2x plus 2, we cannot factor that. But that doesn't mean that we can't solve this equation. We can either complete the square or use the quadratic formula. That will always provide us the solution. So let's identify A, B, and C. And let's go ahead and find the discriminant first, b squared minus 4ac. So b squared is 2 squared, which is 4, minus 4 times 1 times 2. That's 4 minus 8, which is a negative 4. So that's telling us that this equation has no real solution. But it wasn't asking us to find the solution to this equation. It was asking us to find the solution set for this inequality. So what does that mean for us here? Well, it's going to help us think about what the picture looks like. We know that x squared plus 2x plus 2 is a parabola, and since a is positive, we know it's a parabola that opens upward. And since there was no real solution to this equation, we know that it doesn't cross the x-axis, that there are no x-intercepts. So what values of x will cause this x squared plus 2x plus 2 to be greater than or equal to 0? Well, the whole parabola that has y-coordinates that are positive. So the solution set for this is the entire real number line. Any value that you pick on the number line and you plug it in and do this arithmetic, you're going to get a number that is bigger than 0. We've already determined that you're never going to get 0. So our solution set is all real numbers from negative infinity to positive infinity. All right, so let's take a look at this problem in number 8 and see what we have. Let's take this inequality and just set it equal to 0 and solve. I'm going to multiply everybody by a -1 to make sure I don't make any silly sign errors. And 0 times -1 is just still 0. So I don't need an x method here. I've got two terms, and I see that x is common to both of those terms. So I have some number x times x plus 2, and this would give me solutions. Well, if x were 0, 0 times anything is going to get us 0, and if x were equal to -2, that would give us 0. So on my number line, I have 0, well, -2 is to the left of 0, and so I needed to decide whether I'm going to include or exclude those from my solution set. So I look at the original inequality and it says strictly greater than 0. So I'm going to exclude those from my solution set. I'm not going to shade those in. Now, when I go to look at this -x squared minus 2x, that's a parabola that opens downward. That leading coefficient is negative. So if I think of what the sketch would look like, it's a parabola that's opening downward like this, but it has these two values as the x-intercept. So what portion of this parabola is greater than 0? Well, it's the portion here that's above the x-axis. It's the portion, these x values that are between this -2 and 0 will give me y values that are above the x-axis. If you're less than -2 or greater than 0, those x's will give me y values that are below the x-axis. I want to be strictly greater than 0, so I want my solution set to be between -2 and 0, excluding the endpoints. So there's my solution set, my answer for problem 8. You're not going to become an expert on these overnight. You're going to have to practice, ask questions, but you will be able to understand it eventually. Hope this helps, and I'll talk to you later. Bye.